Hello and welcome to SudoKanard. This puzzle is a birthday present by my good friend Glum Hippo. It's called the AE, which is a dedication to me, I guess. And it has a very unique set of rules. Well, not that unique after all. It's just plain Kira Sudoku and little Kira Sudoku if you look closely. So that's a little Kira. It means that 40 is the sum of all the digits on this diagonal. 10 here is the sum of all those three digits and so on. And we also have Kira Sudoku, which means that in each cage all digits are different. So those 7 digits are all different. And their sum is given in the top left corner. Except that you must be wondering why I'm talking nonsense. Obviously, the sum of 7 different digits will never be 0. But the special rule is that some of the digits in the grid are negators, which means that those digits are counted with a minus sign. For example, this 5 could be, well, let's say 3 plus 6 minus 4. We could have this 4 be a negator and those be just regular digits. And then we would have 6 plus 3 minus 4, which would make a legit 5. 5 as a sum. And what's more is that each digit from 1 to 9 is used exactly once as a negator, and that exactly one negator appears in each row, in each column, in each 3x3 block. So I've already made a long attempt at this puzzle. I finally broke into it, and then I just broke the puzzle, and it was not on video. This is my first try on video, so I can use the knowledge that I've already found previously. So let's begin with just identifying where some of those negators have to be. For example, this 0 sum, this 0 cage, obviously has at least one negator. And it's true also for this cage. And considering that in columns 3 and 4, only 2 negators occur, we can deduce that all other cells in those columns must be, well, non-negators, positors, not sure, but positive digits. I just color them green, and I will use purple for clearly identified negators. That's something. Well, let's look at this and look at that. 5 as the sum of 3 positive digits is not possible. So there must be a negator somewhere in here. And look at this, 7 digits. If I try to put no negator, well, 0 is nonsense. If I try to put just one negator, it will mean that this digit is the sum of all 6 others. That doesn't work. So there are at least 2 negators in here and 1 negator in here. So for those 3 columns, we already have located grossly 3 negators, and we can't have more than 3 in those 3 columns, so all of those cells must contain no negators. So that's something more, that's really interesting. And we know that there are exactly 2 negators in here and 1 in there. Oh, 1 in there, which means that on this row, the only negator has been globally located. Then, what can we see? That's true. What else can we see? Oh, what else I can see is that we know that there are 2 negators in here. So at least one of them is here. And we know that there's 1 negator in here. So we have globally located 2 negators in those 2 rows, and it means that the other digits in here are not negators. And something else is that we know there's one negator here and a second one here. So there's only one negator in this part of the cage, and the other negator is here. So that's the first purple cell that I can just locate with certainty. And this means that all the rest of this column and of this region and of this row can be colored green. Now in this area only this cell can be a negator, and it allows me to color all of those cells green. Now in this region only this one can be a negator. Oops, sorry, that's the wrong color. So now on this row all of those can be colored green. And then on this row, on this fifth row, this has to be a negator, and that's true also for the cage. So those two cells can't have negators. So that now I know that on this row the negator is here. It's not there. And on this row the negator is somewhere here, so it's not there. So there has to be one in here, one in there, one in there, one in there, one in there. So that's the first part of what we have to see. And the next place of interest should definitely be this area. So we know that there are exactly two negators, which means that two digits are worth the other 5 digits. And the minimum sum for 5 digits is 15. 1, 2, 3, 4, 5, that's 15. And the maximum sum for 2 digits is 17. So there are not that many possibilities. So what can we see? Not sure about what we can see. So no, I think the next place of interest should really be this 40 sum on this diagonal. Because we already have 2 negators. Can we have any more negators than that? Could we have a third negator on here? If that is the case, let's recall that all negators are different. They are a set of the digits from 1 to 9. So if that's the case, then those 3 digits have a sum of at least 6, and the remaining digits must have a sum of at least 46. But those are 5 digits, and 5 digits can't have a sum bigger than 45, so that doesn't work. 45 being 5 times 9, obviously. And this works with any other cell than this one, so we can't have a third negator on this diagonal. So that's not a negator, and that's not a negator. So the missing negators are here, there, and there's still some ambiguity about this, and that. I did something very wrong here. I colored this purple instead of green, and conversely here. Now, so those 2 digits must have a sum somewhere between 15 and 17. So they are all at least 6, and they can't be 7 just by the rules of Sudoku. So 2 of those digits have a sum between 15 and 17, and they must be different. So they are either, they can't be 6 and 8 because that's only 14, so they must be 6 and 9 for 15, or 8 and 9 for 17. And that's interesting. So the sum here is at most 17. And those 3 digits have a sum of at least 6. So the maximum sum we can have here is 11. And what was I think? So the maximum here is 11. So let's pencil mark 4 and 7. They could very well be 5 and 6. So let's just consider the maximum option. Here the maximum option is 9. Here it's not 9 because we know that one of those two has to be a 9. So maximum option is 8. And here the maximum option is with an 8 and a 9. So the maximum sum here is 17, 26, plus 11, 37. That's it, 26, 37, 45. So we have a maximum of 45 with all those cells, which means that those negators have a total sum of at most 5. So this is at most 5, and interestingly, this is the sum of those two digits, so this is at least 3. And because this plus that is at most 5, this is 3 or 4 at most, and this can't be more than 2. So that is some very good restriction about those digits. And then what? What else can be interesting in here? So there's still one degree of freedom because the minimum sum with those two is 4 and the maximum is 5. So we know that this 40 sum is either 45 minus 5 or 44 minus 4. Well, to be honest, the memory I had of all of this is that it was much more restricted. But there's something here to be noticed, is that if I had assumed this to be a 6-9 pair, then the maximum here wouldn't be 11, it would be 9. And then nothing in here would work. With a sum of 9 here, I would have a maximum of 9, 26, 43, and there would be no possible choice for those two digits. So we can eliminate the 6 from here. So this is an 8-9 pair after all. So this can no longer be an 8. And the maximum value here is actually 7, which brings down the degree of freedom. So now the maximum sum is no more 45 but 44. The maximum sum for those digits is now 44. And this is actually green. And the maximum here is 4, so that has to be a 3. That has to be a 1. And we are in the extreme case, so that has to be a 9. That has to be a 7. And those two really sum to 11. But this can no longer be a 7. So it will be 4, 5, or 6. And this will be 5, 6, or 7 correspondingly. And the remaining 3 digits must be 1, 2, and 3. This is not 1, this is not 2. So that's a nice start, but not an easy one. Well, that's typical Glum Hippo, I guess. Now, what about this 5? Here we have 9. 9 plus this minus that must be 5. So I think this must be 4 less than that. Is that correct? Let's say this is 1, then this must be 5. 9 plus 1 minus 5 is 5. So that's correct. So that's one option, actually. 1 here with a 5. 2 is not available. 3 here would work with a 7 there. 4 would work with an 8 there. No, 8 has already been put into the negator, so 8 is not available. So we get a 1-3 pair here. And what does it tell us? If this is a 5-6 pair, then this has to be 7 with a 3. If this is a 7-4, then this is a 5 with a 1. That seems to work. Oh, about this 3. That's the sum of those two digits. So that's 2 and 1. And that's a real 5. Really the sum of those two digits. We can't use the 1. That's 2 and 3. And here the other 5 is with 1 plus 4. Right. What next? So what could this be? This digit is the sum of those two. This can't be a 1 or a 2, so that's a minimum of 3. This could still be a 1, I guess. So this is at least 4, but there are lots of options. Well, 8 and 9 are no longer options. But it could still be... Oh, actually, 1 is not available, because we know there's a 1 in here and a 1 in there. So we already have 2 1s for those 2 rows, so that's not the 1. That's a minimum of 2. So this is a minimum of 5 and a maximum of 7. So those won't be too big. But well, there are still options. Alright, so this 2 is suspicious. Oh yes, yes. There has to be a 2 among the negators. And this 2 is in the white part. But then in the white part, this does not contain a 2, and this does not contain a 2, and this does not. So the negator, the 2 negator is in here, the -2. And we get another negator here, and the last of them is here. So all negators have been located. And one of them must be a 1. It's not this one. It's not this one by Sudoku. So the 1 is here. Oh, sorry about that. The 1 has been located already. It's here. So we need 4, 5, 6. The 4 is not here. Because of this, the 4 is not here. So it's here. And this is 5, 6, or 7. Right. So we have 5, 6, 7 triple in those 3 cells. Interesting. Now, how do we move on? I still haven't used the remaining little killer clues, but my guess is that this 20 will be the final disambiguator. This 10 could be interesting. This 20 could be interesting. Not sure exactly how. Is it about doing some Sudoku? How could this 5 work? I'm looking for what I'm supposed to see. This 9 is not here. It could be on either side of this row. This 4 here goes somewhere in there. That doesn't seem to be very useful. So this 3, there's a 3, oh, there's a 3 somewhere in here. That's probably about this zero gauge. There has to be a way of finding which sum it is. Or perhaps I can have a look at 2's. There has to be a 2 somewhere in here. And there's a 2 somewhere in here. Really not sure where to look. Is it anything to do with those 2 digits? I know that their sum is 11, but oh, this 9, this ambiguous stats, which is not that much, but that's 2 digits placed, which is still something. So what about this? What if I don't put the 2 here? If I put the 2 in there, then I know that I don't have a 1 in there because that's the 3, that's the 1, that's the 4, that's the 1. So the minimum value is here 3 plus 4. It's 3 and 4 to put the 7 in there. Oops. I'm just having a look at what happens, and now all this is making perfect sense, it seems. Right, so if I don't use, so if I put the 2 in here, then this is 3, 4, and 7. What if I put the 2 in here? Then that's the 2. And here, this is from 3, 4, and 5. And I'm not sure that anything is wrong with that. Which is quite bobbins, if you ask me. Well, in all instances, this is from 3, 4, 5. So where is 8 on this row? Definitely not here. It could be here, it could be there. Oh no, 8 wouldn't go here because of the sum of 10. So 8 is here. So there's an 8 in there. This is, because this is 3, 4, or 5, this is never bigger than 4. So that's 2, 3, 4. That's not a 3. This. And so on this row, 6 is in one of those 2 cells. Is there something wrong with 4 here? 4 here puts the 1 there, the 4 there. So that's the 1, that's the 7. 5, oh, and 3, and this cage doesn't work. Yes, that's correct. So that's not a 4, and therefore this is not a 7, so this is a 5, 6 pair, and this has to be the 7 with the 3 to fulfill this 5 cage. And this 3 puts the 1 there, the 4 here, and the 1 there. And this is still some progress. With this one and those ones, I can put a 1 here by Sudoku. 4 is not here, it must be there. I still need a 5 and a 6 somewhere. This 4 here puts a 4 somewhere in there. This 10 must be important, but there are quite a number of options for 10 as the sum of 3 digits without using the 7, so that's one less option. But the options for 10, we still have 1, 3, 6, 1, 4, 5, and 3, 4, 2, 3, 5. So is there anything to be eliminated from them? One sure thing is that 8 is still among those. Let's just recall that those are not candidates, they are just options for the decomposition of this 10 little killer poo. I don't see anything wrong with any of them. So is there any more restriction on that? If that's the case, I'm not seeing it. This 9 is sort of interesting. There's a 9 in here. This 20 clue doesn't seem to be so restricted. Is it about taking both of them at the same time? We know that those 7 digits sum to 30, which is an average of 4 and something, so that's really not constrained. And we know that all 5 digits here, there's not that much freedom for those 5 digits, because they don't contain 9, 7, or 8. So they are all between 1 and 6. So the sum is between 15 and 20. And the sum of the missing digits is between 10. So that's between 10 and 15. That's still a lot. Oh! So that's between 10 and 15. So that's between 10 and 5. So here the sum of the 2 digits is at most 10. And at least 5, or at least 6, to be honest. So at most 10, so this is at most 4. That's 1, 2, or 4. Well, is that really useful? What about digit 6? 6 is here or there. If I try to put the 6 here, then 10 will be achieved with 3 and 1, and that's the only way. So that's a 5. That's not 1. This must be 8, and this must be the other 2 or 4, and that's actually a 4 and a 2. So in this case, is it just possible? I have 7 here, I need another 13. And I think there's no option for this 13, because 8 and 5 is impossible because of this 8, 6 plus 7 is impossible because of this, and 4 plus 9 is impossible because of this and that. Ooh, that was a bit convoluted. Yes, that's a way of removing 6 as an option from this cell. So 6 is in here, and that's a 5. So that was really convoluted way of removing this option, but it did work. So, what do we deduce from that? This 10 is not 127, it's not 136, it can still be 145 or 235. But one sure thing is that it includes a 5. And because of this 5, the 5 will have to be here or here. And then we have a 6 among this 20 sum. Is this 2-3 pair interesting at this point? Oh, actually, this 2 or 3 is interesting, but because now this can't be a 5 anymore. And you would tell me that this 5 told us as much. And this 7 tells us that it can't be a 7 anymore. And there's a 5 up there. So that's a 6, and the only way of having this is with 4 and 2 there, and 3 and 2. And on this row, we need the 5 now. That's some real progress. So here, those 2 sum to 5. That's not a 3 nor a 2, so the only way is with 1 and 4, and that's a 2. And here this is a 3-8 pair. Progress. 8 there, so the remaining 2 digits sum to 12. They are not 9 plus 3, they are not 5 plus 7, so that's 8 plus 4. And that's 8 and that's 3. And that's the 4. Here I need a 9 and a 6. Here I need a 1 and a 9. Here 2, 3 and 5. Here 6, 7, 8. One in this region can only be here. That's 5, 6, and 9. This, on this row, I still need a 3, 5, 6, 9. Because of this, that's not a 9. Now, this 20 sum is absolute. Oh, this 7 is a negator. We must remember that. So here we have 5. So those 3 digits must sum to 15, which is the most useless clue we can have at this point. So here I still need 1, 5, 6, 7. So 1 and 5 are not here, so 6, 7 are not here. And this is actually a 5, and that's the 1. This 9 removes this option, so 9 is here. Here I need a 7 and a 3. Here, the 7 on this row is here, that's an 8. So the classic Sudoku part is just unfolding before our very eyes, so that's 8 and 5. The knight 8 pair is now resolved. That's a 6. And that's a 7. This can only be a 9. And that as well. That's a 3 actually, a 5 there. And a 7 here. How is this just happening? That's classic Sudoku. I shouldn't ask. So 3, 4, and 6 in here. So 4, 6. 3, 4, because there's a 6, 7 pair in here. So what's going on in here? On this column I still need a 9, it can only be placed here. This is 2 or 4. On this row I still need 4, 5, 6. There's a 6 here and a 4 there, so that's the 5. So 2, 4, and 8. And this point is the reason why there is this 20 sum. So let's recall. 4 plus 8 minus 7 is 5. We need another 15. There's a 5, so this plus that must be 10. So that's the 4, that's the 6, and the rest should just be straightforward, I hope. And I hope I'm correct. That's the 4, that's the 3, that's the 6. And, well, puzzle doesn't include solution, but I think I fulfilled all the conditions. So, very, very nice puzzle. It's not that often that I solve puzzles so difficult on the channel. And I don't think I should do it more often because, well, that's the specialty of cracking the cryptic, definitely. But I'm very glad I did this one because it was Glum Hippo's birthday present to me, and that's something I truly treasure. So thanks, Philip, for this really, really great puzzle, really great surprise. Thanks for watching this video. See you soon on SudoKanard.